This video will be focusing on the concepts of solving equations and the different techniques we have for doing this. Here I have tried to write out a step-by-step process for solving equations, but the truth is that really there's no one step-by-step guide that you can follow that works for every single equation out there because they vary so much. So really, I have these guidelines here, but in summary, I want you to just focus on using opposite operations to isolate your variable. When you see something being multiplied by the variable, do the opposite, which is divide. The opposite of adding is subtracting, and the opposite of exponents is radicals. So sometimes your order will change. That's why, like I said, it's kind of hard to write a step-by-step process. So what I've written out here is to first try simplifying each side of the equation. And by that I mean look for places to use the distributive property or to combine like terms. Next step, try to get all the variables on one side of the equation and the constants on the opposite side. And usually this is done by adding and subtracting terms from both sides of the equation. And then finally, that's where you try to get rid of any of the coefficients on your variable. So this is usually the multiplying or dividing step. I did also write a comment here that if there are absolute value bars in the equation, I see these get handled incorrectly by a lot of students. So first, just treat the absolute value bars themselves as if they were the variable. Ignore everything on the inside for the time being and just isolate the absolute value bars. So anything outside of those, you either add and subtract it or multiply and divide it to get it to the opposite side of the equation. Once you've done that, you actually make two different equations out of what's inside the absolute value bars. One time you take the inside and you set it equal to what's on the other side of your equal symbol. The other time, you take whatever's inside the absolute value bars and you change the sign on everything on the opposite side of the equal symbol. So you should end up with two very similar looking equations. It's just one of them has opposite signs from what you had written originally. And I will show an example because sometimes it's easier to show you what I mean than to try to describe that in words. So if you're following the steps I showed in the last slide, I said first look for any distributing. So I'm going to write this out as 3 times x minus 6 and set that equal to 12. Next, move all of the non-variable terms to the opposite side of the equation. So the opposite of subtracting 6 is to add 6, which will leave me with 3x equals 18. And then get rid of your coefficient. So the opposite of multiplying by 3 is dividing by 3, which means my final answer will be 6. Now I will mention that I gave you this step-by-step process, but it was not the only way to approach this problem. You could have actually just divided both sides of the equation by 3 right from the very beginning, and then you would have had x minus 2 equals 4, and then you would add 2 to both sides of the equations to get the exact same answer I have listed here. So many math problems can be approached in different ways, and really the best thing is to teach you to try to look ahead and kind of plan out what you're doing so that you can pick the shortest or fastest method for solving your particular equation. That's why it's hard to write a step-by-step process, because a lot of times there aren't even just one possible route to get to the solution that is valid. This next example has absolute value bars. So what I was trying to instruct you to do was to first get rid of anything outside the absolute value bars. I have 2 times the absolute value of x minus 1, so I'm going to start this off by dividing both sides by 2 instead. And that will leave me with the absolute value of x minus 1 equal to 4. Now what I'm going to do is I'm going to ignore the absolute value bars, and I'm going to write x minus 1 equals 4. And I need to write a second equation, which is still going to be x minus 1. Don't change anything inside the absolute value bars. Only change what's on the other side of the equal symbol. So before I had positive 4, now I'm going to flip that sign and make it negative 4. If there were multiple terms, just flip the signs on all of those terms. So common mistakes, I see people just change that minus inside into a plus, but that is not something you can do. That changes the value of the equation completely. So now I have 2 separate equations, and you're just going to solve each of them. So if I add 1 to both sides here, I get x equals 5. And then if I add 1 to both sides of the equation here, we get x equals negative 3. And many equations will have more than one answer. In fact, that's going to be the next thing we look at in more detail. Quadratic equations frequently have 2 answers. And so this is just another example like that. Sometimes your solution might have multiple numbers that can be plugged into the original equation and make a true statement. Solving quadratic equations gets trickier because there are multiple techniques based on the specific numbers in your equation that you're working with. So one technique is that sometimes you can just take the square root of both sides of the equation. However, this only works when you do not have an x to the first power in your equation. If you have an x squared term and a constant term, then a lot of times you can just move the numbers to the one side and take the square root of both sides. What I wanted to emphasize with this bullet mark here is that if you ever perform that operation of taking the square root of both sides of an equation, that's when you get a plus or a minus and you get 2 different answers. So a lot of people forget to do the plus or minus. That only happens when you're taking square root of both sides of an equation to solve it. Personally, the technique I usually go to first is factoring. So usually I like to take a quadratic equation, move everything to one side so that I have something equal to 0, and then factor if possible. If you can do that, then the zero product property says if a number times a number equals 0, then either the first one equals 0 or the second one equals 0. So what you get to do is solve for each of those 2 factors separately. So you have to set the equation equal to 0. You can't have a bunch of stuff set equal to 3 to use this. You have to move everything to one side, then factor it, and then you can solve each factor equal to 0 on its own. And then the last technique, this is kind of my last resort. If factoring doesn't seem to work, or if you think it might work, it would just be very difficult and the numbers might be hard to figure out, you can always just use the quadratic formula to get your solutions. And so I've rewritten the quadratic formula here for your reference. This gives you 2 answers because of the plus or minus here. So this number plus this number and this number minus this number should end up giving you 2 different solutions once you plug in the A, B, and C values. So for our first example, this one actually matches what I was describing in the first bullet. I have an x squared term and I have a constant term, but I don't see an x to the first power anywhere in this equation. So what you can do for this is get the x squared by itself on one side. So I'm going to divide both sides by 2 in this case. So the opposite of squaring is square rooting, in the same way that the opposite of the third power is the third root, the opposite of the fourth power is the fourth root, etc. But the main thing I wanted to remind you when you do this, since I am taking the square root of both sides of the equation, this is what I was telling you, that you have to remember that you get a positive and a negative answer from doing this. So it's not just x equals 4, it's 4 and negative 4. Those are my 2 answers for solving this quadratic equation. For this next one, number 4, I do have various powers of x on here, so I don't think I'm going to be able to use that shortcut. However, I do see a GCF. All 3 of these terms are divisible by 2x. So I'm going to start off by taking 2x out. It's always the first factoring technique I check, which would leave me with x squared plus x minus 12. So remember, once I identified the GCF, I was just dividing each of these 3 terms by 2x. So what's inside the parentheses is what was left. Now the trinomial that I have inside the parentheses, I actually think that that can be solved a little bit more. So I'm going to break this down as 2 binomials instead of 1 trinomial. If I didn't think I could factor it, then I could just use the quadratic formula here instead if I would rather. This is the easy trinomial factoring. That's why I wanted to use this method. So I'm going to have x and x for the first terms. Now we need 2 numbers that multiply to negative 12, but add up to positive 1. So this would have to be positive 4 and negative 3. So now that I have everything as factored as possible, you can take each of these 3 factors, the ones inside the parentheses and this one that I wrote out front, and set them each equal to 0 on their own. If you solve 2x equals 0 and divide both sides of the equation by 2, you still have x equals 0. If I write x plus 4 equals 0 and solve that equation, then I would be subtracting 4 from both sides of the equation, which gives me negative 4. And the last one is if I have x minus 3 equals 0, I can add 3 to both sides of the equation, and that gives me the answer of 3. So I actually ended up with 3 different answers from this equation. We'll talk about how many answers to expect more in later detail in the class, but basically the biggest exponent on x, that should be how many different answers you expect, for the most part. So that's why I got 3 answers here. It's because my biggest exponent was a 3. And that's all I wanted to go over for solving equations. Thank you, guys.